Hello and welcome to another creative coding video. Today we're going to be looking again at using maths functions to create interesting designs. We looked at it last time and we covered quite a lot, and the video was quite long, probably the longest we've done actually. Today we're going to be doing a much shorter video looking at just one simpler example and just making sure that we see how using maths for deciding where we place shapes on the canvas, how that actually works. So let's remind ourselves about maths functions. In the last video we started from scratch and we worked with numbers in a spreadsheet. If you need a reminder, do go back and look at the first part of that video. But for now, just a reminder, we can have a math function like y is x, which is very simple, and all it says is when x is 0, y is 0, when x is 1, y is 1, when x is 2, y is 2, when x is 4, y is 4. You couldn't get simpler. Let's look at another one. Y equals x squared, which is saying y equals x times x. And you can see this one curves up much faster. It's not a straight line. So if I take the other one away, you can see more clearly that when x is 0, y is 0, because 0 times 0 is 0. When x is 1, y is 1. When x is 2, y is 4, because 2 times 2 is 4. So it's bigger already. When x is 3, y is 9. 3 times 3 is 9. So it's gone off the of this display. Let's zoom out of it so we can see that. And when x is 5, 5 times 5 is 25, so it's all the way up there. So this one gets big quite quickly. Let's do another one. The one that we liked last time was called sine, y equals sine x, and we liked it because it created a really nice wavy shape, and as I said last time, we're not going to go into the mathematical details and the algebra and where it comes from today. You can do that if you're interested, and it is interesting where it comes from, but for us today we're just interested in its shape, which is a smooth up and down motion. So when x is 0, the sine of x is 0, and as x gets bigger, as I move along here, x goes 1, 2, 3, 4, 5, the sine of x goes up and then down, and then up and then down. And if you look even more closely, you'll notice that it goes up to 1 and down to -1. It doesn't go above 1 and doesn't go below -1. So there is an upper and lower limit. So let's use this interesting shape. We'll create a simple pattern. We won't be overly ambitious today, but I still think with simplicity we can create interesting designs. So I'm logged into Open Processing as usual, got my simple library enabled as usual. Got simple in the setup section there, as we always do. I've started typing already, nothing special here. So I'm setting no stroke, which means my shapes, your circles and squares, won't have an outline. They'll just be filled without an outline. And I'm using the fill color red. Again, this is stuff we've done lots of times before. I'm using a repeat instruction with a loop counter. We've looked at these in previous videos, and if you need a reminder, do go back. But just to recap, a loop counter starts at, in this case, 0, counts up to 800 in steps of 10, and for every one of those numbers this function is called, and it's something we have to write, and at the moment it's empty. So this will keep a count from 0, it'll go 10, 20, 30, 40, 50, all the way up to 800, and it will pass that number to this function. My math function, I've called it, and it's here. And you notice this time I've got a little x in here. I could have called it something else. I could have called it A or I. X makes sense, but I have to have that because it's receiving a number. Now inside the function I can do what I want, but I'm going to use that x to calculate a y using a maths function. So if I had something simple like y equals x, that's the first example we looked at, and I drew a circle at x, y of size 5 say, that should draw that line we saw, because x will be going from 0 to 800 in steps of 10. We're calculating a y, which is actually the same as x, and we're drawing a spot, a red spot at that point. So let's see if that works. It's a straight line. It's going in the other direction, and just a reminder why that is. Normally we have 0 in the bottom left, and x goes to the right and y goes up. But in this language that we're using, x and y start at the top left, not here. So not here, but here. So x increases along to the right as before, but the y increases downwards. If I'm honest, I wish they hadn't done that, because the convention is bottom left, but that's where we are. But it's easy enough to deal with. If we wanted to pretend that we were starting, say, here, we could just say we don't plot at y, we plot at 600 minus y. That means it'll move up like that. Let's see if that works. Let's see, 600 minus. So it's what it would have been, but it's taken from 600. Yep, that makes sense. That worked. So now the origin, as it were, has moved to the bottom left. That's the effect of doing that. Okay, now let's see if we can use our sine function. There you go. So we would have had y equals sine x, which is that wavy thing, and hopefully this creates a wavy pattern. Let's try it. There's something going on at the top of the canvas. Maybe it's because we forgot to shift the origin down. Let's move it down halfway. Why 300? Well, if I said 300 minus y, then this becomes the origin. So our straight line would go up from there. Let's see if we improve that pattern. No, it's still a series of dots that maybe look like they're going up and down a teeny bit. And the reason is sine x goes only up to 1 and down to minus 1. So it's not going to be very tall. So we multiply it. There we go. So what we're saying is, whatever sine x comes out to be, the maximum it'll be is 1, and the least it'll be is minus 1. And we can just make it bigger by multiplying it by 100. So if it was 1, it'll become 100. If it was minus 1, it'll become minus 100. It's a way of stretching it vertically. Let's see what effect that has. Yep, that's nice, isn't it? Yep, a nice simple curvy wavy thing. Let's do something else with it. Now let's use our sketchpad here to think of something else to do. Now those sine values go up and down. Wouldn't it be nice if we could draw little rectangles that went up, maybe like that? Not sure what the exact sort of size will be, but so they'd be following the sine shape and the sine shape will decide the height of those rectangles. So this is a tall one, and that's when sine is maximum, and this is over here would be small or 0, and here they're negative, aren't they, but still quite tall. So the sine goes like this, but we're not plotting a circle at those points. What we're saying is we're plotting a rectangle of that height. Let's try that. Let's take it step by step. Let's remove our code just to give us a clear thinking space. So we know that we're going to be drawing the rectangles along the canvas at position X, so that can stay the same. We want them to have a certain height, not a height, we need I need to change it to rectangle first, don't I? Rectangle, there. So it needs a position and a height. Let's draw what I mean there. So if I have a rectangle like this, the first two numbers describe its position, which are 500 here and 100 down. And then the next number decides the width, so that might be 100 here, and the height down. So let's make a tall one. So that one is quite a big one, and that's 200. There you go. So that's rectangle. So it needs four numbers: x, y, width, height. So x and y, what is y? Well, let's start the rectangles to always have a corner along the middle of the canvas, so it's always 300. What does that mean? Let's clear this canvas a bit. So if I'm drawing a rectangle at x, 300, it means it'll be somewhere along this line and through the middle of the canvas, because it's 300 down, 300 down, and x across. So it might be here. That would be 200, 300. And let's say it's got a width of 5. That means it's going to be quite thin. And then a height, let's call it h, which is calculated from height from sine. And as it moves along, that height will change because the sine wave goes up and down. So we've got x 300, a width of 5, and a height. Let's call it h. We haven't calculated h yet. Let's do that. Var h equals sine x. Well, we know that's going to be tiny because it goes up and down to 1 and minus 1. Let's multiply that by 100. Does that should work, shouldn't it? Let's see what happens. Yeah, cool or what? Really nice. A tiny little point, it doesn't really matter, but the sine here is going down first instead of up first. Do you remember this one goes up first, and that's because we should have used a negative to go back up the canvas, because on this canvas y grows downwards. So if I just change that y, that h to minus h, that'll give it the right direction. Don't worry about that, it's just a tiny point. Okay, so that's nice. I mean, we could stop there. What we've done is we've created a design, a pattern made of rectangles which vary in height, and they vary in height according to a maths function, the sine wave. And the sine wave has a nice shape, and so this pattern has a nice up and down shape. What I'm going to do is just to add a little thing to it, just to demonstrate that it doesn't take a lot to make a design a little bit more sophisticated. And I'm going to use a sine wave again. So let me make this rectangle, let's see, let's add another one, rectangle. I'm going to draw another rectangle with it, so it's going to be at the same place, X, same corner, X300, but I'm going to make it thinner. Let's say it's width 3, not 5 but 3, so it's thinner. And I'm going to make it taller, so it's not the height, but height times, I don't know, 1.3. Let's see what effect that has. Before I run it, let me think through what that'll do. So this rectangle has a width of 5 and has a height of h. This new one, it's going to be, let me pick a different colour. It's going to be thinner, so width of 3, and taller by an extra half, because I'm multiplying it by 1.5. So it should get, well, I don't know, it should get a series of red rectangles, and thinner rectangles overlaid the thicker ones. Let's see the effect it actually has. Cool. That kind of reminds me of some kind of electronicsy 1980s music, feel, kind of maybe the cover of an album of dance music or electronic music. I like that. That's it. Just a really simple thing we did there. We just added another rectangle that was thinner and taller, and it created this really nice effect. Let's do that again. I'm going to do let's try a different colour. So if these are going to be red, I'm going to do a different one. Fill blue. It also means I don't need this one up here because I'm setting the colour down here. So this one, let's say rectangle. By the way, you can use the word rect or rectangle. Rectangle X, 300. Let's see. Let's make it even thinner. 2. And let's make it not so tall. So maybe 0.5. That means half, so it's half the height. What will that do? Let's change colour again. And that will be thinner and half the height, so not as tall as that, about there. So this one will have a width of 2 and half the height. Let's see what happens. Nice! That's really rather nice, isn't it? Yeah. I wonder if I can make it even thinner. I think the blue's dominating a little bit. I wonder if you'll still be able to see it. Yeah. Just another little experiment. Maybe I will make those blue ones a little bit taller. Yeah, that's a nice effect. So it's kind of not as tall as the tallest one, but not as short as the shortest one. Yeah, I like that. But you can experiment yourselves. I quite like that. And of course, you're not restricted to rectangles. You could always add a circle. Let's say circle X. Where is this going to be? 300, and it's going to be. So it's. Where's that circle going to be? So if I have a X here, X is the same, yeah, and Y for the circle. If I wanted to do a circle at the top, it would be 300 minus H. So 300 minus H, and a small size, let's say 3. Let's see what effect that has. Interesting, yeah? Kind of cool. Just increase that circle size a bit just to see what happens. Nice. Yeah. And of course, if I didn't, if I flipped it to go in the opposite direction, it would do that, which is also an interesting design. If I did the blue line like that, I'm having too much fun here, aren't I? I should stop. That's interesting too. Yeah, that's interesting. I'll leave it like that, I think. Yeah. So I will stop there. We don't want to make another very long video, but what you've seen is how we can use a mathematical function like the sine wave, and we can use the values it gives back to us for the height, for example, of a shape, like these rectangles and circles, and it allows us to create an interesting design without a lot of effort. So I hope this shorter video has helped. The last one was a bit long. What I might do is, again next time, have another short video using a different mathematics maths function, maybe the exponential decay. This one was just looking at the sine. Cool, okay, well I hope you enjoy that. See you next time. Bye.